Hello everybody. So per your request, the last two homework problems on chapter 4 had to do with the net present value of a guy making $100 forever, and it's gonna the initial investment would be $100,000, and he gets $100 forever. And some of you asked me basically, how do I know the time frame? How do I get the net present value if I don't know the time frame? Well, the time frame is right here, and it says forever. And when you see the word forever, the first thing you should think of is right here, this term here called a perpetuity. So that perpetuity should lead you to the present value of a perpetuity, which is this, simply C divided by R, the payments divided by the interest rate, which they gave you as 9.5%. So when I do this simple division, I get a present value of $1,053, and if I then use the net present value equation right here, where I subtract the 1,053, the present value, from the original $1,000 that I paid, it comes out that I'm going to make a positive $53. So the correct answer is accept the machine, because the net present value is greater than 0. Now, for the second part, they told you to wait a year, miss a payment, wait a year before you start. Takes 1 year to build before you start printing out the money. The equation in that case is, it says here, and I don't expect you to know this equation, but I want to show you how you can do it without dealing with the equation. You got to combine the formula for the present value of the perpetuity and then the present value of a future amount. So basically, this will give you the perpetuity, and then you just basically divide that by R to get the present value of a future amount. And they do that here and come up with $961. So if you wait a year, because you have to build a machine, what you'll notice is that this is now 961 and not 1,053. So when you do the present value for part B, for waiting the year, you'll notice that, whoops, sorry about that, you'll notice that it comes out to minus $39. So you're negative, so you don't do this project. Now, the thing I want to mention is, if you don't know, or you couldn't figure this equation out, we can use Excel and trick the problem easily using Excel, and I will show you how to do that. What I did was I made a fake perpetuity using Excel's net present value function, and I did a longhand, and I typed $100. I typed $100 many times, and I'll show that to you, and you'll see you end up with $961, and effectively, then when you do the subtraction of 1,000, you'll get minus 39. So let me just show you what I did in Excel, and you could try it, but it takes a long time. Now notice, what I want you to notice is in Excel's NPV function, right? Here's the NPV function. I put the interest rate of 9.5, and you could have done it this way, 9.5, as I taught you, right? Percent, right? Now, the first year you had to build a machine, so you didn't print any money, so that was 0. Everyone see that? Okay, so then I went crazy, and for the next, what I did was I typed $100 for, hold on, let me get to where I was here, and I'll show you. I typed $100, and I did it for 93 times. So I just kept typing 100 and typing 100, and I'll just scroll, and you can see this, right? So see how I type? So it thinks it's going on forever. And I could have kept going, but I kind of got tired and I stopped. So as you can see, the net present value, if I skip a year, comes out here to $961. Okay? So there it is, and that's what they calculated with their equation, which you didn't have to use. Okay? You could have just, did this longhand to prove it to yourself. And then I'll say, okay, and there's the $961. So, going back to the problem, do homework, you can clearly see there's the 961 that I did longhand. Or you can memorize this equation here. I don't know if this was in the book, but basically they do it in two parts. The present value with the perpetuity, then you go out 1 year. Okay, so anyway, that's how that's done. This was the easy one. Okay, so the whole concept here is the net present value using the perpetuity function. Okay, so let me close that. And let's go on to the next problem. And I think that's probably, the British government has a console bond outstanding, paying $100 per year forever. And I think that's the same concept, right? The interest rate is 4%. And so we click on here to get the answer. So here's the value of the bond is equal to the present value of the cash flows. Again, here's a perpetuity equation, and where C is the annual cash flow and R is the rate. And the present value is basically $2,500. That would allow me at 4% to pay $100 forever. I get 100 British pounds, right? So the next question they asked, let me just move this out of the way. The value of the bond immediately after a payment is made. Well, I'm sorry, hold on. The value of the bond immediately before a payment is made. And before a payment is made, the value of the bond is equal to the present value of the cash flows. The cash flows are a perpetuity plus the payment that will be received immediately, right? So basically, the present value is $100 divided by 0.04, and basically, after the payment is made, you add that, and remember, it's worth $2,500 forever. So the value of the bond immediately before a payment is made. So that is done right here by adding $100 to the amount, and that'll be $2,600. Here's before the payment is made, right there. So anyway, I hope these are a little clearer now. And so before a payment is made, you end up with that 100. All right. So but again, you don't have to worry about these equations, because you could simply again trick a net present value in Excel into doing this by typing it many times. And basically, this is just the perpetuity equation. All right. I hope everything's clear. If not, email me. All right. Thanks a lot.